Hello everyone, welcome back to our open course. My name is Shengan from Hangzhou Firstack Technology Company, and I am the technical marketing of Firstack. So today we will talk about how to build a double post test platform, and the content will be divided into parts. The first part is about the theories, and the second part I will bring you to our lab and show you how to build the platform and also show you how to process the test by our test equipment. So now we can start our today's course. Okay, now welcome back to our lesson. Today's topic is how to build a double post test platform. In this class, I will introduce some basic theories about the building of double post test platform, and in the end, I will bring you to our lab and show you how to build it and how to process the test by our test equipment. So this lesson will be divided in two parts. First, three chapters here are all about the theory, and the last chapter, practically build a test platform, is real application. Now we can go to our first chapter, composition of double post test platform. Here in this slide, there are two pictures. The left picture, we can find a complete test platform, and in right picture, we can see the topology of it. As we already mentioned in our first lesson, we will test only our bottom IGBT as an example. Therefore, we will give negative voltage to the top IGBT and keep it always be off. So from the left picture, we can see there are a lot of different test equipments. They can be divided in 5 parts: the power supply, power stack, load, measuring instruments, and signal generator. So in power supply, we can find adjustable high voltage DC power supply, which is used to provide 1000 watt of power, and also we need a low power supply to power our GPU. And the next part is power stack. In power stack, we can find the DC caps, laminated busbar, also IGBT, and the GPU on it. Sometimes we will use a snap cap to help us to process our test, and there are some other structural components like the screws. And the next part is the load. We use variable air core inductor, and in next part, measuring instruments, we can find oscilloscope, high voltage differential probe, voltage probe, current probe, and also isolation transformer. So this equipment are basic test instruments we require for DPT test. So if you have some special requirements, you can also use some special instruments, but I won't go too much details here. And the last part is about signal generator, which is used to create double pulse signal. So this is the composition of DPT platform, a very general view of it. And in next chapter, I want to show you how to record the data after the test, after we get the waveform. So before we start recording the data, we need to know which data we need to record. And actually, I have already mentioned some of them in our first lesson. I list several parameters here for IGBT and diode respectively. For IGBT, we will measure like VCE and IC, the collector emitter voltage and the collector current. I have already mentioned them in the first lesson, so I think you should already know it. And the next 4 parameters are the time characteristic, which are TD on, TD off, TR, and TF. They are the turn on and off delay time, and rise time of the current, fall time of the current, and also the next 2 parameters are the E on and E off, the energy loss during the on and off process, and the last two are voltage current rate of change, which is related to the EMC level. And from that, we will measure the voltage and current during the reverse recovery process of it, and also we will calculate the power and energy loss during that time moment. So all of these parameters can be summarized in just 4 classes. I also give you a table here, and they are the security boundary, data time settings, heat evaluation, and the EMC level. So we can start from the 4th class, because I have mentioned it, that voltage and current rate of change is related to our EMC level. And the EMC value we calculated should be close to the value defined in the datasheet. Now it won't exceed too much, but if it exceeds too much, then your EMC may influence or interfere the normal operation of the system or the normal on and off process of our IGBT. So then we can go back to the first class, the security boundary, which include voltage, current, and power. So these parameters need to be observed during the complete process continuously. We need to ensure that they won't exceed our SOA. It's very important to keep safety during the test. And the second class is about the delay characteristic. Actually, we talk about the time characteristic here. We will use them to set our data time and modify our sequence management, which is very important for 3-level system. And in the future coming lesson, I will also introduce how to process the double pulse test in 3-level system. Now our example is about 2-level system. And the third class is about loss, power loss or energy loss. We use them to evaluate the heat generation. Actually, we can say in another word, we use them to evaluate our system efficiency. So now we know which kind of parameters need to be recorded. Then I want to give you an example and tell you how to read the data from a waveform. Here in this slide, I use delay characteristic as an example. In another word, you can say it is also time characteristic. Before we start reading, there is one important point we need to pay attention to. I also write it below this waveform. Different module manufacturers have different definitions. Definitions for what? Definitions to read the data from the waveform. So different module manufacturer will have different standard to define the turn on delay time, rise time, and also turn off delay time and TF, the fall time. So it was very important when we process a test. Firstly, check the standard from the module manufacturer. Today we use this IEC standard, which is defined by Infineon. So when this point is clear, we can start reading the data from this waveform. First time parameter we want to read is the TD on, the turn on delay time, which is the time duration between 10% of gate voltage to 10% of the current. As we know, firstly, the gate voltage will be negative before the IGBT is turned on. After we turn on IGBT, the gate voltage will increase to the rated value. But before the voltage reach the threshold of IGBT, there won't be any current because the IGBT is still off, it didn't be turned on. And therefore we name this time interval between that the current start increasing and the voltage reach the threshold as turn on delay time. And the next time is our TR, the rise time, which is calculated from 10% of current to 90% of it. This time is the rise time, and TD on plus TR is our T on, which is the complete process of our on. So there is another point I want to note you that during the test in actual application, there will be some oscillation during the test, especially, for example, for the current waveform. So if we have oscillation, normally in this situation, we will choose that the first time the current reach 90% of it. The oscillation behind it will be directly ignored. This can be caused by many factors. For example, the external test environment because of module characteristic, and also the quality of the current probe is very important. And we have another time characteristic TI, which is from 10% of gate voltage to 2% of VCC. So this time characteristic, you just need to know how it is defined. It is not so important for us to evaluate the delay characteristic. So in next slide, here is our off process of the waveform, and we will use the same method to read the data, so I won't go further with too much details here. You just read or record the data, just follow the same method I mentioned before. Okay, now we go to the next part about some notification of test. This notification is summarized from our daily work and our test experiences. So I think they are very useful for you in your study and your work. So the first point is clean your table. Clear DPT platform layout is clean your table. It's very important. Don't left any dirties or extra components on the table which will cause short circuit or unexpected conducted loop. And the high voltage cable and the low voltage cable are separated and kept away from each other. This is to avoid the coupling between them, which will cause abnormal waveform and even lead to the blow up. Okay, and then we go to next part. Is the second point is test probe circuit as small as possible. To test accurately, the measuring instruments and the method need to have high accuracy, and theoretically, the smaller the circuit is, the less interference and error the probe will generate. So it's very important to keep the circuit as small as possible we can. And the next point is, third point, we must test the voltage on auxiliary terminals, not power terminal, because the voltage will be much lower in some module when you use power terminals. So please remember it. It's very important if you want to get high current waveform. And the next point is test with actual complete power stack. If you just test the IGBT alone with peripheral circuits and then evaluate the performance of a complete power stack, it is not advisable because the devices and circuits are different and the test result will be inaccurate. And then the next point is the cables from pulse signal generator to GDU need to be as short as possible. The reason is similar compared to the second point, because long cable will lead to the interference. So actually we want the circuit be small, we want the cable be short. All of them, our purpose is to prevent the interference from external environment and the coupling between the cables between the module and our power stack, and it's the point we need to focus on. And the next point is for drive pulse. A 15-volt signal is recommended because it is also an interference immunity method. If you use 5-volt level signal, wave filtering needs to be strengthened. So then last point is DC side voltage and current are gradually increased during the test. Because before the test, we might calculate theoretically to have one certain expected voltage and current. But during the test, we won't recommend you reach the voltage and the current suddenly or directly. It's better to gradually increase from a low voltage or current step by step to the expected state. Because for the first time we evaluate power stack, we don't know which operating condition will exceed the SOA of it. So to keep safety, we should observe the corresponding parameters, for example, the voltage and the current continuously during the whole increasing process of the voltage or current. So if you directly increase your voltage, for example, to the 1000 volt, if your voltage peak exceeds the threshold of your module, then you will damage your module, or even worse, you will make explanation. It can be possible sometimes, so please be careful about this point. And the next slide, I want to show you some effect of gate resistance on IGBT characteristics. So they are very important for you when you want to change the gate resistance, because during the test you change the gate resistance frequently, because maybe you want to increase efficiency or suppress the voltage peak, and then you need to change the gate resistance. So please remember this table, read it carefully, and you can also take a note. So I think it will be helpful to your real application. So this is all theories part about today's lesson. So in next part of this lesson, I will bring you to our lab and show you how to build the platform, and I will use our test equipment, which is designed and manufactured by Firstack, to show how to process the double pass test. So then see you in our lab. Bye.